Hey friends, day 5 of our Bellringer. Let's get it done. We're going to identify the place value of the underlined digits. So remember, for this problem, I do not want you to tell me the place value position. So for example, for the 5, don't tell me that that's in the 10th place. I already know that that's in the 10th place. I want you to tell me that this 5 has a value of 5 groups of 1/10 or 5/10. And you can write it like this. You can write it out in words. I don't mind how you write it. But I want you to tell me that it has a value of 5/10. Then do the same thing for the 8 and do the same thing for the 7. So when you're done, you'll have 3 statements that explain the value of each of those underlined digits. Next, we're going to change 26/4 to a mixed number. So this one up here. 26/4 in mixed number form is going to be 4/4 plus 4/4 plus 4/4 plus 4/4. Oh my goodness, lots of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 plus 4/4. Okay. That gets me all the way up to 24/4 plus 2 more fourths. That gets me up to 26/4. So 24/4 is the same as saying 24 divided by 4, or 6. 1 whole, 2 wholes, 3 wholes, 4 wholes, 5, and 6. And then 2/4 in simplest form is 1/2. So 26/4 has a value of 6.5. Okay, next let's do the volume problem. We're going to calculate the volume of a figure with length 20 centimeters, width 4 centimeters, and height 1 6/10 centimeters. Now the volume formula is length times width times height. And I can start by multiplying 20 times 4 because that's easy to do in my head. That gives me 80. And then I'm going to multiply it times 1 6/10. So in order to do this part of my multiplication problem, remember, with the US algorithm for multiplication, you don't have to worry about lining up the numbers by place value. And you can just go ahead and start multiplying. So 6 times 0 is 0. 6 times 8 is 48. You're done with your 10th place, and don't forget the 0 as a placeholder. 1 times 0 is 0, and 1 times 8 is 8. Add your 2 partial products, and you get 1,280 square centimeters as your product. All right, let's go ahead and tackle our line plot problem. We're going to organize this data onto a line plot, and we'll use an X to represent each piece of data. I'm seeing a lot of people leaving the X's off of their line plots, so do make sure that you include that. 14/2 can be read as 14 divided by 2, which is 7. And 10/2 can be read as 10 divided by 2, which is 5. So those ones were easy to do. Now we have 6 2/3 and 5 5/10. So I'm going to leave 6 2/3 alone and change 5 5/10 to fraction form, and then put that in simplest form, which is 5.5. 6 2/3, actually, all right, so 5.5, I'm actually going to put that in 6. So that'll be 5 3/6, because 6 2/3 I can put as 6 4/6. So now we have a common denominator to work with. So we have 6 4/6, 5 3/6, 7 5. So I'm going to start my line plot with the number 5, and I have one piece of data with that value. 5 and 3, 6 will go right here. 6 and 4, 6 will go right about here. Don't forget your X's. And then 7. And that's it. Yay! Done with the dreaded line plot. That brings us to our last problem. 321 and 8/10 is equivalent to how many meters? Okay, sorry. 321 and 8/10 millimeters is equivalent to how many meters? So a millimeter is super tiny. It's like about the size of just the white part of your fingernail. It's very small. And a meter is like about as long as if you stretched out your arms, you know, like flying like an eagle. If you stretched out your arms as far as they could go, your arm span is usually about a meter. So obviously we're going fly to horse, divide of course, because we're converting from a smaller unit of measurement to a bigger one. We're going to divide 321 and 8/10 by 1,000 millimeters that are in each meter. And in order to divide this, I'm simply going to move my decimal point over 3 spots, 1, 2, 3 spots to the left, because my number needs to get smaller as I divide. 1, 2, 3. So that's our meters. 3,218 10,000ths. Or you could also round that to 322 thousandths of a meter. Oh gosh, that's a tough one. Okay, now we're going to take 9,876 and 32 hundredths of a gram and convert that to milligrams. Now a gram is like about the size of a sugar cube, you know, like what your grandma would put in her tea if you were to bring her some Sunday tea. That's about a gram of sugar. And a milligram is 1,000th of this quantity. So it's, if you took that little sugar cube and cut it into 1,000 equal pieces, one of those little pieces would be a milligram. So this is a case of horse to fly, multiply. Smaller to bigger, multiply. We're going to take our 9,876 and 32 hundredths times 1,000 milligrams in each gram. Put in some zeros as a placeholder. We've got to move this over 1, 2, 3 spots. 1, 2, 3 spots. That's a big number. Okay, so that gets me to 9,876,320 milligrams. And that's it. All right, remember, show your thinking, make me proud.